Welcome back, guys. This is the next video in our series. This one is focusing on image samplers, which is quite similar to attractors in the way that it is a good introductory into Grasshopper, and it gives you the opportunity to get results out quite simply, and it's a good introduction into a few new tools and components. Before I get into Rhino, I just wanted to bring your attention to another resource that I forgot to put online in the PDF that I uploaded for everyone. And this one is called Parametric House. They have some free tutorials and examples, and also some premium ones that you have access to if you pay. But even the free ones, there are some good resources available on here as well, so it's worth exploring. Okay, let's boot up Rhino and Grasshopper. Okay, so before we get into Grasshopper, let's create something in Rhino that we can use to reference back in. Let's type in rectangle and hit 0 on the keyboard for the start point of the rectangle, and that will set it up in the origin. And move the cursor out. And let's say that we're going to make a building that is 15 meters by 15 meters footprint, so it's just a square, and in the elevation, let's type in extrude curve, press spacebar, make sure this is set to solid. If it's not, just click on it, and we can say that this will be, I don't know, something like two stories. Let's go 6.5, enter. I'm in meters, by the way, so if you are in millimeters, that's totally fine. Just make sure you put in the correct units. So in your case, it would be 15,000 by 15,000 by 6,500. And this is what it looks like in perspective. It's just a box, but what we're going to do is we're going to treat this as a facade. Maybe to give you a bit more context, we might duplicate this and make that as, so there you can see there's 2 stories. And just for the sake of finishing up, we'll just put a door so you can get a sense of scale as well. I'm just going to put in a rectangle, 3-point, start. Right, so there's our door. You don't need to do this. This is just to kind of give it some context. Again, I'm going to move this down to the lower left view so you can see while I'm working in Grasshopper the top view and perspective view. Now we're going to start by double clicking on the canvas and typing in surface. Before we can reference in our surface or our facade to work on, we need to explode this solid or this BF into single faces. So click on the poly surface. So if you type in explode, you'll see that now we can select the individual faces of this box. And that's what we can import into our container here. Click on the facade, right click on the component and hit set on surface. You can now go back to Rhino and type in hide, and that will just allow us to see the Grasshopper surface without needing to see the Rhino geometry. Similar to the attractors from the previous exercise, we now need to generate a series of points that we can use. In the previous exercise, if you can recall, we set up a rectangular grid, and then we used that grid to generate center points. In this exercise, what we're going to use instead is divide surface. If you hover your cursor over it, you can see that it allows you to generate a grid of points on the surface. Let's put our surface into S, and by default we have 10 and 10. And you can see we've got 10 rows of 10 columns. The number of points you have, the more resolution it will have. However, if you put too many up straight away, you might find that your computer will struggle. So it's about finding a balance between how much computer power you have and how good you want the resolution to look. Let's double click and go 20 for now, and go 20 in the U, 20 in the V. You can see we have a denser grid. Let's start there. We can always come back later and increase that. The next thing is to generate our image. So similar to the previous exercise, we had a point or a curve that you could use to generate a pattern. Now we're going to use an image. Double click on the canvas, type image sampler. Image sampler. It looks like this because there's no image. So the next step is to go to Google and let's find a image of a black and white. Let's go zebra. It doesn't always have to be black and white, but it's an easy way to explain how it works. Let's see if we can find a nice side on what we do. So save the image, put it on my desktop. Boot up Photoshop. Rather than measuring distance from your attractor point to each of these individual points, what we're going to do now is we're going to apply an image onto that surface, and whatever color is in line with that point, it will read that information, and that will translate to a number which we can then translate to a distance or a size or a radius. Okay, here's my Photoshop. The reason I want to Photoshop it is I just want to crop it down to its body, its torso. That'll do. And while we're here, let's make it black and white and just desaturate it. It's worth doing, and then we can save this onto the desktop as a JPEG. It's fine to replace it. Just minimize Photoshop. To import an image into the image sampler, you double click, go to File Path, Desktop, and bring in the image, and press OK. One step I forgot to mention is that we need to go back into the settings, so double click, and just make sure we have the channel set to black and white, or color brightness. And so what that means is if you can imagine that image mapped onto this facade, any of the points that fall in the white will have a low or a high value depending how we set it up, and the inverse is the same for any points in the black. So we can now generate a series of zebra stripes on our facade, and we'll start off by driving a radius of a circle using this image. So what we need to do now is, we know we want to use a circle, so we might as well put that down on the canvas and work back from that. So the circle needs a base plane for the center point. You can see by default, circle down there at the XY origin. What we need to do is create a plane on each of these points that are facing the XZ, and that's XZ is, if I turn this off, that plane that we are working in at the moment. You can see that down there. We're going to put an XZ on each of our points, and I'll just change this display again to make it smaller, and now you can see a new planes are generated, and we're going to put a circle at each of those planes. Right now the radius is huge. Make them smaller so you can at least see what's happening. I'm going to turn these two previews off, and there's our grid of circles. If I didn't set up the XY plane and I just put these points straight in, we would have had all the circles but running vertically and facing the wrong orientation. Put that back in there. If you can remember from the previous exercise with the attractors, we used a remap value and a bounds. The reason for that will become apparent in just a second. So let's take our UV points, which are the points in X, Y, but across the surface. Pop that into the input for the image sampler and get a panel on the desktop. And here we can see a series of numbers generated from our image. And again, just to reiterate what is happening here, let's say point 0 is this point here. That point falls on a black area of the image and it's producing a low number. And for argument's sake, let's say point 1 is falling around the midpoint and it's falling on a white, we have a larger number. We can use these numbers to drive our radius and replace this input here. So let's select that and move that into R. Right, so it's not really looking how we want it to look. And that's because I've forgotten one crucial point. We've divided up a surface by 20 and 20, and we're applying an image to that surface. But if you can think about when you're using another software and you're doing a render and you're trying to apply an image to a surface, you need to get the mapping of that image right. So at the moment, we likely have many tiles of this image across this surface. So what we need to do is something called reparameterize, which means that we're going to remap this surface from 0 to 1, which will then make sure that this image is mapped across that entire surface. So to do that, we need to go to the S input, or we can go to the surface input itself, right click, click reparameterize. You can see now something's starting to happen. However, our scale is a little off. The next thing we can do is create a series of remapped values, like we did in the previous exercise. Let's double click and type in remap. Turn off my caps. We're going to put these values in as our values to remap. Our source domain is our bounds. Let's put that in, and before we plug that into S, right click on the N input and flatten our list. Here you can see we have a data structure 0, 0, 0, and this is basically our series of columns and rows that we see here. We have 0 to 20, so we have 21 points in our column, and then if we scroll right down to the end, we have 0, 0, 20, which means we have 21 columns. 0, 1, 2, 3, 4, and so on through to 20. If we flatten our list, we now get, if I show you what it looks like without it flattened, you'll see. We get a minimum and maximum domain, but only for each column when it's not flattened. So what we need to do is make sure that it is flattened, and then we get the overall minimum and the overall maximum. We can put that into S, and then our target domain means we need to construct domain. That goes into T, and if you can remember, we set up 2 sliders last time. Putting a number of decimal points just gives us a little more control over our minimum and maximum numbers. I'm just going to bring that down and put that R into the radius and turn that back on. And this is where we control our maximum radius and our minimum radius for our facade. And you can start to see the zebra stripes coming through. There's that little B that we see there. Now be wary about pulling these numbers too far up because you might crash your computer, but I'm just going to increase mine. I've got a pretty fast laptop. And you should be able to see that now nicely replicating our image. Obviously we have some overlap, and that's not what we want, so I will need to bring that maximum number down. And there's our variable facade. If I turn that to a boundary surface, Again, if you're going to do this, maybe start with lower numbers before you plug that in, because you may crash your computer. That took 1.1 seconds to compute. I'm just going to drop these back so we can run a little smoother. And I can increase my panel size. So we have a facade with a series of circles that you can think of as discs. Another thing we could do, adapting what we've learned in the previous tutorial, is we can play around with rotation. So for example, let's say I want to rotate those objects in the Z axis. I'm going to take those circles, I'm going to take them before they become surfaces, so this runs a bit quicker. The rotation and the axis. So I'm going to create a line SDL and use that as a center point. And that gives us a series of Z lines as our axis. And I'm going to plug in a slider into the angle. If you read that bubble, it says rotation angle in radians. We need to right click and change that to degrees. We can pop in a slider. We'll turn this off. And now you can see the panels there can rotate. If you can imagine we're tracking the sun, and we'll sketch that out for you really quick. Let's say that's the sun path. It's very schematic, but what I am suggesting here is that if we have a point, I'm going to bring in this curve, right click, set one curve, I'm going to hide that curve. Now we can get a point on the curve, bring that down into the canvas. And what this does is it treats the curve as if it was already reparameterized, meaning the distance is now 0 to 1, and this slider goes from 0 to 1, and you can see that point at 0 starts on one end and at 1 finishes on the other. Let's say that's the sun. And just to diagram this out, I'm going to draw a series of lines from each and every point on our facade to this floating point. I'll make that a bit bigger, hopefully it's clearer. Now we have what you could say conceptually is our sun as that point, and these are our sun rays hitting every one of these discs. As this sun starts in the morning and tracks across to the afternoon, what we can do is set up these discs to follow that sun. I've more or less given you the base structure for this. The answer lies in the previous exercise, so I'm going to stop here and give this to you guys as homework, and then we can talk about it next time we catch up. But what I want to get you guys to solve is having these discs as circles. It's probably worth waiting to make them circles to the very end. And we want to be able to see you move this slider and have those circles rotate on their own axis, but following the sun path. Okay, I'm going to leave it there for now, and the next video I'm going to show you how to use a similar setup, but rather than creating a series of points to put on circles or triangles or hexagons, we're going to look at how to generate a three-dimensional surface.